Hello everyone. Warm welcoming to all. I hope you all are fine. This is Sekar, statistician from Department of Community Medicine. Today we talk very interesting subject, that is statistics. Statistics are used in virtually all scientific disciplines such as physical and social sciences. As well as in business, statistics is fundamentally a branch of applied mathematics that developed from the applications of mathematical tool. Don't forget, if you are dealing with numbers, there is a function is statistics. Okay. So, introduction to statistics. Statistics means science of figures. The word statistics come from Italian word statista. So, statista means it's a statement. A German word statistic, it's called a political state. Statistics is a science and art of dealing with the facts and figures. So, father of statistics, he is Sir Ronald Almer Fisher. His time's greatest scientist was British statistician and biologist who made significant contributions to experimental design and population genetics. So he is widely regarded as father of modern statistics and experimental design. So, father of Indian statistics. So, any idea about this gentleman? So, he is a Professor Prasanth Chandra Mahalanobis. India launched its 5-year annual plan in 1951 under the socialist influence of India's first Prime Minister Jawaharlal Nehru. First 5-year plan was mainly focused in the development of primary sectors and continuous. The second plan is called as Mahalanobis plans. It's known as India's second plan, proposed by Prashant Chandra Mahalanobis from 1956 to 1961. The second 5-year plan on the development of the public and rapid industrialization. So he is a founder of Indian Statistical Institute, Kolkata in 1959. So the National Statistics Day of India is observed on 29th of June in every year. So father of biostatistics. So he is a Francis Galton is called a father of biostatistics. Why he is called a father of biostatistics? Let's see. He is create the concept of correlation. He was the first to apply statistical model to the study to human differences and inheritance of intelligence. So going to the subject, definition of statistics. Statistics is science of collecting, organizing, presenting, analyzing, and interpreting data to help in making more effective decisions. Statistics is a field of study concerned with techniques or methods of collection, classification, summarizing, interpretation of data, and drawing inferences, testing of hypotheses, and making references. Don't forget, if you are dealing with numbers, don't forget there is a function of statistics. So, definition of biostatistics. A biostatistics is a branch of statistics applied to a biological or medical sciences. Biostatistics is also called as biometry. Biostatis, biostatistics is the term used when the tools of statistics are applied to the data that is derived from biological or health sciences such as medicine, biology, nursing, public health, and etc. In Greek, bio means life and metron means measured. So it is a measurement of life. So biostatistics is also called measurement of life. So before we are going to any subject, we have to know the practical applications of particular topic. So what are the wide applications of biostatistics? To define what is normal or healthy and what is abnormal, to identify signs and symptoms of particular disease, to establish the accuracy of diagnostic procedure, to assess the efficacy of new drug, to compare the efficacy of particular drug. Efficacy can be assessed accurately on ideal conditions when patients are selected under by proper criteria and strictly adhered to dosing schedule. Thus, efficacy is measured under expert supervision in the group of patients most likely to have a response to a drug, such as in controlled clinical trials. To find an association between two attributes such as cancer and smoking and filariasis and social classes. Planning of experiments, analysis of results in health field to assess the treatment protocol and collection, analysis and dissemination of various population health sciences. So before going to depth, what are the terms are used in statistics? We need to know. So first, a data, a set of value recorded on one or more observation unit, the factual information collected during studies. So data can come in the form of text, observations, figures, images, numbers, graph, or symbols. For example, data might have include individual prices, weights, addresses, ages, names, temperatures, dates, or distance. So next, variable, the characteristics that take different value in difference or things. An attribute that varies, that is taken on different values. For an example, body temperature, body weight, number of siblings, sex, and etc. In simple words, a variable is a quantity that can be changed and it's not fixed. So next, observation, an event and its measurement of such as BP and corresponding their values. Here, event and measurement are observed. That is, event is BP and measurement like 120 bar 80 mmHg. Next, population. The entire set of individual or objects having some common characteristics, that is called population. For an example, all registered doctors in India. So next, sample. A subset of samples selected to participate in study that represent the entire population. So population refers to the entire group or set of individual objects or even being studied, while a sample is subset of population that is used for analysis. So we can see in this picture, there are a lot of, I think, two common characteristics are there. If you want to analyze the red mark, that is our sample. The blue and red are our overall population. We want to analyze this one particular color of this person, so it is called sample. So next, if we are getting a data means, so scales of measurement. In statistics, the variables or numbers are defined and categorized using different scales of measurement. Each level of measurement scale have specific properties that determine that varies use of statistical analysis. So before going to scales of measurement in statistics, we need to know what is scale. A scale is a device or an object used to measure or quantify any event or another object. Okay, there is a four levels of scales of measurement, that is nominal measurement, ordinal measurement, and ratio and interval. Psychologist Stanley Smith Stephen created these four levels of measurement in 1946. So first, nominal measurement. It involves the assignment of numbers to represent categories or classes of things. This measurement normally deals with only non-numerical variables or where numbers have no value. For an example, gender, sex, and marital status, college course, blood type, etc. See, here all the examples are having a categories. For an example, we are taking a marital status means that is married, unmarried, widower, widow, like that. And then sex, we have male and female, like that. Only it is category based. So, example for in blood group, they are categories wise of blood groups. And ordinal measurement. It ranks object based on the relative standing on the specific attribute. The order of ranking is imposed on categories. The numbers must preserve some level of order by do not need to precise. For an example, both are nominal and ordinal or both are categories, but one difference between ordinal and nominal is ordinals have a some specific order. That is, for an example, if we are taking a health status, there is a pre-structured order, that is poor, fair, good, and etc. In income status, low income, middle income, and upper income. So this example, if you are having a if you are running a one company means the one particular product you have to sell. That is how they are liked your product. Don't like, tolerable, like a lot, and loved. Liked a lot and positive have a positive, and near liked it's a neutral. So it have a some order. So, interval measurement. In this level, there is a specification of ranking on object on an attribute of the distance between those objects. There is more or less equal numerical distance intervals. There is no absolute zero because there is no 0 point or absence of concept. Think if body temperature is zero means already patient is died. Okay. So for an example, temperature and ratio level measurement. It is the highest level of measurement. It has all three attributes: magnitude, equal interval, and absolute 0 point. It represents continuous variable. In biophysical parameters, weight of children versus adult, weight of children versus adult, and height of children versus adult, and body blood pressure, like that. Next, the comparison of four scales: nominal, ordinal, interval, and ratio. If you are doing a marathon means you are assigned to the numbers randomly. In ordinal, based on their performance, you are giving a ranking: first place, second place, and third place. In interval scale, performance rating scale based on the 0 to 10 scale, how they are performing in the marathon. So who having a highest scale, he must be the winner, first place, and continuous in second and third. In ratio, time to finish, who finished the run very who finished the marathon very easier, that is called ratio. In qualitative data, variable that cannot be measured numerically, it is known as qualitative data. For an example, eye color, residence, and etc. When the quantitative variable does not follow specific order fashion, that is termed as nominal variable, like gender and religion. When the variable assume an orderly pattern, it is known as ordinal variable, like dehydration status, like that, which can be placed on no hydration, some hydration, and severe hydration. We can tell us nominal and ordinal comes under qualitative data. So, and quantitative variable. Variable that cannot be measured numerically, it is known as quantitatively variable, like age, weight, blood pressure. When the variable takes all possible values, including fractions, it known as continuous variable. For an example, weight and height. It can be comes under fractions and decimal points. It is a continuous variable. Sometimes some variable can only expressed in whole numbers, like pulse rate is known as discrete variables. For an example, number of pages in a book, outcome of dice roll, and petals in flowers. These are discrete. Quantitative data tell us how many, how much, or how often is calculation. In quantitative data can help us to understand how, why, how, or how happened behind certain behaviors. So transformation of qualitative to quantitative data. For an example, it have a continuous variable like height and weight. You can categorized like, for an example, we are taking height means we can categorize into short, medium, and tall. If you are taking a weight, na, you can underweight, normal weight, and overweight, and so on. So independent and dependent variable. It is variable that stand alone and it's not changed by the other variable you are trying to measure. It is also called explanatory variable. For an example, age, gender, and etc. Dependent variable. A dependent variable is the variable that changes as result of independent variable manipulation. For an example, BMI, health status, exam results, etc. So independent variable is standalone and it's not changed by the other variable. But dependent variable, it manipulation of independent variable. So association of two or more independent variables is called dependent variable. So functions of statistics. So collection of data, presentation of data, analysis of data, and interpretation of data. So before going to what are the types of data collection, before going to collection of data, we need to know what are the types of data. That is, we have a two types, that is primary data and secondary data. So source of data. Primary data are those which are collected from the unit or individuals directly, and these data have never been used for any purpose earlier, that is questionnaire, interview, and etc. And secondary data are data which had been collected by someone individual of agency and statistically treated to draw certain conclusions. Again, the same data are used to analyze the exact some other information are termed as secondary data. For an example, published thesis, research paper, projects, reports, and etc. So before going to collection of data, where there is a various method of collection of data. So we can see one by one. First, observation method. This method refers to the collection of information by the way investigators' own observation without interviewing the respondents. Okay. And interview method. In this method of collection of data, in terms of oral or verbal responses, is achieved in two ways. That is personal interview. In this method, a person known as interviewer is required to ask question face to face to the other person. The personal interview can be structured or unstructured, direct investigation, focused conversation, and etc. And telephonic interview. In this method, an interviewer obtains information by contacting people on the telephone to ask the questions or views orally. Okay. And questionnaire and schedule. Questionnaire. List of questions framed relating to the study. In this method, set of questions are mailed to the respondent. They should read, reply, and subsequently return to the questionnaire. The questions are printed in the definite order on the form. Next, schedule method. In this method, similar to questionnaire method, that is slight differences. The enumerators are specially appointed for the purpose of filling the form. Central government initiate the census. There is a government officer or behind the data collection. They are called enumerators. So there is a sample questionnaire, that is they are looking to internet addiction. They are already pre-structured the question, that is approximately how long you've been using the internet and often do you use access the internet, like that. Okay, they're based on the research aim and objective, they are framing the questionnaire. So presentation of data. So data can be presented in three ways, that is text, table, and figures. First, text. Data are presented in sentence and paragraph. For an example, prevalence of hypertension, sex ratio, it is presented by text. For an example, India have a 20% of prevalence in India. in 2024. It is a text format of presentation of data. And table format. A table present data in concise, systematic manner from masses of statistical data. Tabulation is the first step before data is used for further statistical analysis and interpretation. And figures. We can use bar diagram, pie chart, histogram, line graph, and etc. Why we are using figures? We can understand, a simple man also understand what it tells. So before going to analysis of data, what are the various type to analyze the data? We need to know. That is descriptive statistics and inferential statistics. Just go to the depth. So descriptive statistics are brief information that summarize given data set, which can be either a representation of an entire population or sample of the population. So descriptive statistics are broken down to two things, that is measure of central tendency and measure of variability. And inferential statistics is concerned with populations and uses sample data to make an inference about population or the test of hypothesis considered at the beginning of research study. So already we know there is a two type of statistics, that is descriptive and inferential statistics. In descriptive statistics we have a two part, that is measure of central tendency and measure of dispersion. So first, measure of central tendency. Central tendency or central position or statistical average or measure of location, it's all have represent the measure of central tendency, reflects the central point or the most characteristic value of a set of measurement denoted by mean. It is obtained by summing of all observation and dividing the total number of observation. It is denoted by x bar and y. When we use x bar and when you use mu, okay. If you are taking a sample, we can represent mean as x bar. If you are going to population, it is represented as mu. Next, median. It is a middle observation is arranged in ascending or descending order. Okay. It is also called positional average. Next, mode. It is the most commonly frequently occurring value in the series. Measure of dispersion. Measure of dispersion help to find how individual observations are dispersed around the mean of the series. The measure of dispersions are first, range. Range is nothing but it is a difference between maximum value and minimum value of the series. So range is equal to highest value minus lowest value. Okay. Next, interquartile range. It is a difference between upper quartile Q1 and lower quartile Q3, that is IQR is equal to Q3 minus Q1. Next, mean deviation. It is the arithmetic mean of difference of each observation from the mean of the series. Here, both negative and positive are treated as positive. It is mathematically given by mean deviation is equal to summation of x minus x bar by n. Here, x and x minus x bar. So, x bar is our sample mean and n is our total number of observation. Next, standard deviation. It is most prominently used measure of dispersion. It is denoted by SD or sigma. So, definition of standard deviation. Standard deviation is the positive square root of mean squared deviation of values from the arithmetic mean. So formula for calculation of standard deviation in form of discrete data. The standard deviation is equal to square root of summation of x minus x bar the whole square divided by n minus 1. If a data comes under a continuous form, we have a special formula, that is standard deviation is equal to square root of summation of x minus x bar the whole square into f divided by n minus 1. If the sample more than 30, the denominator will be changed n. If less than 30, we are considered denominator as n minus 1. If it is more than 30, we can say as n. So next, coefficient of variation. The coefficient of variation is calculated from standard deviation and mean of the characteristics. The ratio of standard deviation and its mean is found to be percentage. Thus, coefficient of variation is equal to standard deviation divided by mean into 100. So, for before going to end of this session, we need to know what are the basic terms and what are the functions of statistics. So mainly we are focusing on function of a collection of data and presentation of data and analysis of data and interpretation of data. For collection of data, we have a four method, that is observation, interview. In interview, we have a two part, that is personal interview and telephonic interview, and then questionnaire and schedule method. Coming up to presentation of data, we have a three times, that is in text forms, in table forms, in figures form. Next, analysis of data. In analysis of data, we have a two types, that is inferential statistics and descriptive statistics. In descriptive statistics, we have a two part, that is broken down into two parts, that is measure of central tendency and measure of dispersion. So in central tendency, it is represented by the central value, and it can be comes under three part, that is mean, median, and mode. So mean is our summing up of all values divided by n. That is sum of all values divided by given by total number of values. That is denoted by x bar and mu. If a sample, if you are denoting the sample, it is x bar. If you are denoting the sample mean, that is mu. And median. And median is a middle value of when you are arranging ascending or descending. Okay, it is also called positional average. And mode is the most repeated value in a series. Okay, and we have a range, mean deviation, standard deviation, and coefficient of variation. Thank you for this class. I hope you all understand this introduction to biostatistics. Thank you.
For analysis of data, we are using two methods, that is descriptive statistics, differential statistics. Previously, what were the terms and under the descriptive statistics? We are now going to differential statistics. So, while descriptive statistics summarize the characteristics of set of data, in inferential statistical help you can do conclusion and make decisions, make predictions based on your data. When you have collected from a sample, we can use inferential statistics to understand the larger population from which the sample is taken. So inferential statistics have two main uses. That is making estimates about population. For an example, mean SAR score of 11th graduates years and testing of hypothesis. Draw a conclusions about population, for example, relationship with gas growth and family income. Other associations are available in the terms. So, for testing and hypothesis, there is a two tests available. That is parametric, non-parametric test. We can see one by one. This parametric test. In parametric test is a kind of hypothesis test which gives the generalizations and generating record gathering the mean of the primary or original population. This is often to assumption that the population data are normally distributed. In non-parametric test, the non-parametric test does not require any population or distribution, does not mean any population or distribution in distinct parameter. Non-parametric test makes no assumptions. The probability distributions of the observations. Next, one of them Properties of parametric as well as non-parametric test. Our first assumptions. Based on assumption in parametric test, we need a basic assumptions of the population. In non-parametric test, no assumptions are needed. Here's the test and then central tendency value. So how do we know central tendency value? It's a describing the whole population or sample characteristics using one single. There is a lot of central tendency values are available that is going cleaner. In parametric test, we are considered as mean as our central tendency value. Non-parametric test, we are considering median value as our central tendency value. Correlation. So we are taking in parametric, we are taking Pearson correlation, and in non-parametric test, we are taking Spearman rank correlation. Okay. Why we are taking Pearson and Spearman? So parametric tests are based on quantitative data, status, attributes. For an example, weight, height, like that. In non-parametric test, category based. So this comes in the nominal data. Next, probabilistic distribution. It is follows the normal distribution. If it is follow the normal distribution, then only we can go up to the parametric test. If it is not follow the normal probability test, it is skewed. So we are taking this as conflict. So population knowledge. So based on knowledge in parametric test, it is required the basic knowledge about the population. Non-parametric test we do not need does not need a recover does not recover on the proper population knowledge or the hypothesis testing. So which are the scales of data are used in used for interval scaling. In the interval or ratio scale is used in parametric test, non-parametric test, nominal data are used for analysis and applicability. So parametric test applicability in only in variability variables. In non-parametric test, it is applied attributes as well as variables. So next, further tests are available in the parametric and non-parametric test. So parametric test is based on the quantitative test. It has the magnitude. It being taken for a central tendency value. This must be follow the normal distribution. It's normally distributed. So if you are taking one to figure before and after, we can go with paired t-test. Paired t-test. Same set of samples are before and after. If you are taking uh, drug efficacy and before intervention, after intervention, we can choose paired t-test. With this group, we are going to pair the t-test. Unequal samples, unequal variants are used in unpaired to test. If we are comparing DMFT test, this is boys and girls. In these girls, we are using unpaired test. So next, NOVA test. There is a two type. It is one way and two way. It is two groups or more than two groups. We are going to okay. You're comparing with if you are comparing with the two groups with the one single variable. For example, DMFT test and DMFT test versus boys and girls. You are going to Vianova. Or it is DMFT test as well as hemoglobin level. Same boys and girls who are going to Vianova. Next, test availability non-parametric test. In one it is good enough, it is not for all of the normally distributed. And we are going to McNemer test. McNemer test. Then signed rank test. It's two groups or more than two groups. We can go into chi-square test. Chi-square n is equal to less than 30. We are going to chi-square test. If n is sorry, n is less than 30, we are going to get solution is Fisher exact test. So sample error variability MB Samples due to choice versus population. The two differences are just due to the sampling error, the probability error. That is the error is a misleading. It's not a mistake because we are going to any decision, there are certain percentage of margin of error and probability. Probability means that the numerical indication of how likely it is that a given event will occur. General definition is statistical probability. The odds that we are observed in the sample did not occur because of the error. That is called statistical probability. This doesn't prove is that is random error or systematic error. Otherwise, probability is associated with the statistic is the level of confidence we have that the sample group that we measured and should represent in the total population. So, inferential statistics, when we are going to test, we need to find a hypothesis. So, hypothesis is a general statement about the populations. That is a two type of hypothesis. That is null hypothesis and non-right hypothesis. Null hypothesis means not any, no differences between mean. Null hypothesis always is generate no differences between two groups. In alternate hypothesis, there is a significant difference or available. Clear? So, null hypothesis is denoted H naught, H naught. So, example, H naught is equal to V1 equal to mu2. If you are dealing with medicine A, medicine B, are there any changes in this group? No, there is no changes in these groups. There is no hypothesis. There is no changes in both group. That is, both are same. Always testing the null hypothesis. Statistically, we are always testing with the null hypothesis. Either is reject or accept. We can't say accept the null hypothesis or reject the null hypothesis. You accept the null hypothesis. It is obviously will reject the red hypothesis. If you are accept the null, reject the hypothesis. So next, use samples to evaluate the credibility of hypothesis from the population. Hypothesis is a scientific or alternative hypothesis. Predicts that there are differences between the groups. Clearly visible. Unlike hypothesis, there is no differences between groups, but in alternative hypothesis, there is a difference. So V1 and V2, the mean of first group and the mean of second groups are different. They are not equal. What is the hypothesis? A statement about what finding were expected. Null hypothesis is the two group of not differ. Alternative hypothesis, a group A will be better than group B. A group A and group B will not perform the same. First category, first hypothesis, it is state no difference between two groups. Alternative hypothesis, there is a difference between group A and B. Inferential statistics, when making comparison between two sample meets, there are two possibilities. That is, null hypothesis is true, not reject the null hypothesis. When it is null hypothesis true, not reject the null hypothesis. Null hypothesis is false, reject the null hypothesis. So possible outcomes in hypothesis testing decision. So null is true, we can accept that is the correct decision. If it is null is false, in case we are accept null, it is a type 2 error. And null is true, we are reject null, that is type 1 error. So reject and null is false, we accept decisions. So type 1 error, type 2 error. Rejecting the two hypothesis is called type 1 error, type 2 error, accepting the false hypothesis. Hypothesis is in decision right or wrong. We count the probability that meaning right or wrong and specify the control of probability making. Type 1 and type 2 error, try to keep it small. So, what is alpha error and what is beta error? So, alpha error is a type 1 error. The probability of making type 1 error depends on the criteria we use to accept reject the null hypothesis significance level at 0.05. That is, high chances that the difference observed was really due to the sampling error. 5% of the time, type 1 error will occur. That is, we are represented alpha error. Difference observed in real is a sampling error, probability of type error. So when we do the statistical analysis, if alpha p-value is greater than 0.05, we are accept the null hypothesis. 0 point value p probability of value p-value is greater than 0.05, we accept the null hypothesis. If a p-value equal or less than 0.05, we reject the null hypothesis. That is, there is a difference between two means. So it is two day and take. So next beta value. Probability of making type 2 error because when we fail to reject the null hypothesis, it should have difference observed nearly equal to the power. This one is probable. So our findings any error type 2 error is a very familiar error. So we are using power to reduce the type 2 error. So power means ability to reduce type 2 error. So ability to reduce type 2 error 1 minus beta. So type 2 error is called beta error. The power analysis. It is done in three ways. That is the power can be found in effective is present. Increase your area, increase your sample size, decrease variability, precise measurements, effect size, measure the size of difference between means attributed to the treatment. So, to the significance testing, practical statistical significance. So, in future statistics used to testing the mean differences. So, we are already saying t-testing. When experiments in only two groups, be dependent correlated within subject or minus subject based on the t-statistic, depending value based on the degree of freedom as well as level of fraud. So, analysis of variable. We say alpha is to compare more than two values between subject or within subject repeated measures based on their statistics, critical value based on the degree of freedom alpha level. More than one factor, it is factorial analysis. More than only one factor, it is one to all. Yeah. Thank you. I hope you all understood this class. Introduction to biostatistics. In next class, we will see the brief about the parametric and non-parametric levels. What is the test are available? It is test with statistically. Thank you.